Okay, today is Monday. You are in school, but I am not. We're still going to get some chemistry done today. Today we're going to work on problems like this. This is the first part of your brand new unit, Unit 11. And this question that you see in front of you, it says balance the equation in your answer booklet for the reaction between hydrogen and chlorine using the smallest whole number coefficients. And then in the answer booklet, you would have something that looks like this. You have the reaction actually written out, and there are lines in front of each molecule to allow you to balance it. This is a question from a recent Regents exam. The kids who took this class last year faced this question as question number 52 on their Regents exam in last June's Regents. Your goals for today, you want to do a couple things. So you want to be able to balance equations by adding in coefficients to the equation, and coefficients, just like in math class, those are the numbers you're adding in front. So we're going to be balancing these equations by adding in coefficients, and your language objective here to describe how to balance an equation and when you need to do it. So we have the same reaction written out here, and in this reaction, to allow you to see it a little better, we have all of the molecules involved underneath the reaction. We also have it color-coded, so the hydrogen are all in red, the chlorine are in blue, and we have this reaction. Hydrogen comes together with chlorine to form HCl. And looking at the molecules below, it looks like we have a problem, because we have here, there are two hydrogens, and here, there's only one hydrogen. And here we have two chlorines, and here we only have one chlorine. So if you think back to earlier in the year, we talked about the conservation of mass and the laws of conservation of mass. We should have the same number of atoms on the left as we do on the right. Basically what that means is if you have two hydrogens on the left, there should be two hydrogens on the right, but you only have one. So what we're going to do today are work on balancing these equations. And what we mean by balancing the equations are sort of make the equations follow the law of conservation of mass by adding in a coefficient up top right in front of the numbers. And on the left here, this is how we balance it. So when you balance an equation, your choices of what to work with involve adding in more copies of the molecules involved. So we could add in, say, another H2, but we couldn't just add in like another H on its own. So you have to stick to copies of the molecules involved directly. Again, like if you want, you could add in another Cl, but you can't just like write in a third Cl. And with this HCl here, the only thing we could add is, say, another HCl. So, and that's really how we balance it here. And I've added in another HCl, and let's count the H's. We have, for our H's, we have two H's on the left, and now we have 1, 2, and we have two H's on the right, so that looks balanced. And let's check the Cl's. We have 1, 2 Cl's on the left, and 2 Cl's on the right. So that is a balanced equation. So if anyone missed what we did there, all we did was looked at this equation. We have two hydrogens on the left, only one on the right, two chlorines on the left, only one on the right. So to make this balanced, we've added in another HCl. And if this were, say, a question on a test, and you were drawing them below, you would not be complete unless you actually wrote in the coefficients up top. So we look to see what we have. There's no coefficient here in front of the H2, and that means that there is one H2 molecule, which is here, and there's nothing written in front of the Cl2, which would mean that there's one Cl2 molecule, which is here. But now we have one HCl molecule, and now a second HCl molecule, so we would need to put in a 2 here. So the final equation would read H2 plus Cl2 gives you 2 HCl. Moving on to see this same question in another way, we have the same equation here. I've just added in another way of looking at it, because when you get to, say, a test, you're not going to take the time to go in and like draw individual atoms like this. A quicker way is adding in underneath the arrow, listing the elements. And the first thing you should do is list how many elements you have, or how many copies of each element you have when you start this equation and you look and we see for hydrogen, we have 2. So 2 hydrogen on the left, we look on the right, and there is just 1. We look on the left for chlorine, 2 chlorine, and 1 chlorine. And then you balance based off of these numbers here. So we have 1 hydrogen, and we want to make that a 2. So in order to make a 1 a 2, you add in a coefficient up top. Anytime you update a number up top, this distributes into both elements there. So we now, instead of having 1, we now have 2 H's, and instead of having 1 chlorine, we have 2 chlorines. So we look at our equation, and the final step you should be doing in any of these problems is that final check yourself before you wreck yourself step, in which you look and see I have 2 hydrogens on the left, and now I have 2 hydrogens on the right. So hydrogens are good, and I have 2 Cl's on the left, 2 Cl's on the right, so the chlorines are good. So here's another example, and we have the formation of H2O from hydrogen gas and oxygen gas. Both hydrogen and oxygen are those Brinkelhoff elements, so they would never be found on their own. They'd always be found in this molecular form of H2 or O2. So we look at this reaction, and it's also important early on to establish if it's balanced or not. You look at the hydrogens, we have 2 hydrogens, and we have 2 hydrogens. So the hydrogens look balanced here. But then we see we have 2 oxygens and only 1 oxygen here. So this is an unbalanced equation. And some people early on in their balancing chemical equation career would try to balance this by, say, doing this, writing in plus O, and then just, say, drawing in an oxygen here. That is not correct. You do not have the option of just adding in elements on their own. The only things you could work with, once again, are things that are already involved. You could add in more H2s, you could add in more O2s, you could add in more H2Os. So we have this box on the side, which is our bank of all of the particles involved. And the way we're going to balance this is by looking at these particles and adding more of these. So an obvious thing to do here, you only have 1 oxygen, and it needs to be 2 oxygen. So we're going to start out by adding in another H2O. And we look, and we now have 2 oxygens and 2 oxygens. So the oxygens, they're balanced. Check. We look at the hydrogens, however, and there are a total of 4 hydrogens on the left and only 2 here. So to balance this, we're going to add in another molecule of H2. And since there are now 2 molecules of H2, we add a coefficient here, and we added in a second H2O, so we add a coefficient here. And we double check our math, and I'm looking at the hydrogens. So we now have 2 times 2, so 2 times H2, there are a total of 4 atoms of hydrogen on the left, and 2 times H2, total of 4 on the right. Hydrogens are good. Oxygen, we have 2 oxygens, because there's, say, if there's no number written in, it's a 1, so there's 1 O2, which gives us a total of 2 oxygen atoms on the right. 2 times 1, because this is really, you don't write in 1s with a formula, so H2O is the same thing as saying H2O1, there's only 1 oxygen. So if you have 2 H2Os, there are 2 oxygens. So now the hydrogens, 4 and 4, oxygens, 2 and 2, check. This is now a balanced equation. Looking at it a different way, if you were going to, say, do this method, which is the method you'll probably be doing on a test, the first step you would do, list out how many of them you have. Even though we've done this problem already, we're going to repeat it here. So first thing we're going to do is list out how many elements we have on both sides. So on the left, we have 2 hydrogens. On the right, we have 2 hydrogens. And oxygen on the left, we have 2 oxygens, and on the right, we have 1 oxygen. So doing it this way is a really quick way of seeing if it is balanced or not. So we look at this and can tell that, no, it is not balanced because we have a different number of oxygens. So we're going to balance it. So what you could do, you look to see what is not balanced, and in this case, it's the oxygens. So we want to take this 1 and we want to turn it into a 2. The way to do it would be adding a coefficient and then changing all of the numbers below. This not only affects the oxygen, but it also affects the hydrogen. So we have now a total of 2 times 2. So there are now 4 hydrogen, and we have 2 oxygens. So we've updated our numbers below, and now the oxygens are balanced. However, the hydrogens are not, and we have 2 here, and we want to turn it into a 4. So to turn this 2 into a 4, we're going to double it. So we're going to add a 2 in front of the H2. So we add a 2, and anytime you put a number up top, you need to reflect that down below. So we're going to cross out the old number because there are no longer 2, and now we have 2 times 2, so there are a total of 4 hydrogens. So we check our math here, and we have 2 times 2, 4 hydrogens on the left, 2 times 2, 4 hydrogens on the right. Hydrogens are balanced. Oxygens, we have 2 on the left, 2 on the right. Oxygens are balanced. So let's do one more here, and now let's do this one in that second way first. So looking at this one, we are going to balance our equation. The first step that you take is filling in how many of each you have. So looking at our numbers, let's do nitrogen first. There are 2 nitrogens. So 2 nitrogens here, and on the right there's only 1. And next, let's do the hydrogens. On the left, there are 2 hydrogens. On the right, there are 3 hydrogens. So when you balance equations, these are kind of fun. Some people like to sit around and do Sudoku problems. I like to balance equations. The reason why I like to balance equations is that they're kind of satisfying once you figure them out. So if we look at this, you have 2 and 1 for the nitrogens, and you have 2 and 3 for the hydrogens. Something you have to do when you solve these problems is you have to decide what would be easiest to fix first, and then you fix those ones. So what I mean by that is, could we turn a 1 into a 2, or could we turn a 2 into a 3? Which one would be easier? It'd be turning the 1 into a 2. So what I mean by turning a 1 into a 2 is by changing this here. We now want to have 2 of them. So we fix this coefficient. Originally there's 1 nitrogen here. Now we want 2. So we're going to then add in a 2 in front, and that's going to change everything we have down below. So we now have 2 nitrogen, and then we have 2 times 3, so there are 6 hydrogens. So just an aside, when I wanted to turn this 1 into a 2 here, an incorrect way of doing this would be changing the formula to N2H3. The reason why that's incorrect is this reaction where you take hydrogen gas, you add nitrogen gas, and then you turn it into ammonia, NH3. This is the formula you have. These are the reactions. So if you say change the little numbers, you change the subscripts below, you now have a different reaction. You have completely different chemicals. And you cannot do that. The only thing you can modify are these coefficients here. So we have added a 2 here, so now we have 2 nitrogens and 6 hydrogens. So our nitrogens, we have 2 and 2. Those are looking good. And now we want to turn this 2 into a 6. So to turn a 2 into a 6, you want to multiply it by 3. So to do that, you add a 3. Oh, I'm sorry, I put that in under the nitrogen slot instead of the hydrogen. So you want to put a 3 in front of the hydrogen, and this now balances out. So we cross out that 2 because we don't have 2 anymore. We have 3 times 2, so 6 hydrogen atoms. So let's check our math. We have 2 nitrogen on the left and 2 nitrogen on the right. So that is balanced, and our hydrogen, we have 6 on the left and 6 on the right. Visualizing that, the first thing we did, we balanced the nitrogens. So what we did, we originally, and you can see this on the bottom, originally we had 1 nitrogen while we had 2 on the left. So the first thing we did was balance those nitrogens by adding in a second NH3, which you can see below. So now we have 2 NH3s, so this is 2 NH3s instead of 1, and then you can see visually how this changed things. So the nitrogens are balanced, however the hydrogens, you have 1, 2, 3, 4, 5, 6 hydrogens, and on the right you only have 2. So to fix this, we add in another one, and say if we did 2 H2 now, this still isn't enough. We now have 4. So we've added in a total of 3 copies of this. So we have 1, 2, 3, 4, 5, 6, and this balances out with the 6 hydrogens on the right. So this is a fully balanced equation. So when you get to one of these on a test or, say, your homework, you're going to see a problem that looks like this. Often the hints that you will see that tell you that you need to balance an equation are these lines in front, and you'll see these lines in front. That's sort of a dead giveaway that you need to put some numbers there. You need to balance this equation. And oftentimes in the problem itself, it'll say something like, given the following unbalanced equation, or it'll, in the direction, say, balance the following equation using whole number coefficients. And whole number coefficients are important here because to balance this, you cannot say, like, we need half of these and half of these to equal one of this. So the coefficients are always going to be whole numbers. So this is actually the same problem that we did before. We're just going to go through the steps to solving these problems. So step one, you're going to list every element, so each element involved below the line. So just like this, we list out H, we list out Cl. Step two, count each of the elements before you do anything. So we have 2 hydrogens, 2 chlorines, 1 hydrogen, 1 chlorine. Step three, you balance the numbers below. And what I mean by that is you have 1 here and 2 here. We want to balance that. And the way that you balance it is by adding in the coefficients up top. So when you change a number below, make sure you change the coefficient up top. I'd even recommend doing the coefficient first. We want to turn a 1 into a 2, so we add a 2 here. And what you need to do according to step 4 is you need to update all of your numbers. So we now don't have 1 anymore, we have 2. And this 2 here, this coefficient, it's kind of like in math class where you have, say, x plus y. This 2 would distribute in. So this 2 doesn't just affect the hydrogen, but it also affects the chlorine. So we have 2 hydrogens, 2 chlorines now. And the final check yourself before you wreck yourself step would involve you going back and looking at the numbers you have, and then just doing sort of a checkpoint at the end and say, okay, I have 2 hydrogens on the left, and I have 2 hydrogens on the right. And check. Now I have 2 chlorines on the left, and I have 2 chlorines on the right, because it's 2 in front. And now that is balanced. So let's look at one more. Aluminum plus oxygen gives you aluminum oxide, Al2O3. Everyone's favorite crisscrossing problem from the last unit. So what you're going to do here, and it's important to note here, the last couple examples we did involve nothing but nonmetals, all molecular substances, and now we have metal coming in, and then we have a ionic compound here with a nonmetal and a metal. So if that's something that stresses you out because you're having trouble on those kind of distinctions in the last unit, don't worry. It doesn't matter now. We really don't care if it's a nonmetal or a metal. We don't care if it's a ionic substance or a molecule. So remember, your first step here would be step 1. You're going to list each element below the line. We have the aluminum, we have the oxide, and then step 2, you're going to count each of the elements before you do anything. So we have 1 aluminum, so 1 aluminum, and we have here, so let's add our 2. And we look at this now, the aluminums are balanced, but the oxygens are still unbalanced. So this one looks like it might be a little more complicated than some of the other ones. So we might have to attack these oxygens first. So go to the oxygens, and we have a 2 on the left, and we have a 3 on the right. It is not possible using whole number coefficients to turn a 2 into a 3 or a 3 into a 2. So you have to think about things that you could turn both of those numbers into. So 2 and 3 both go into 6. So you want to end up having 6 atoms of oxygen here and 6 atoms of oxygen on the right. So you want to turn this into a 6, and what you could do is add a coefficient of 3. Now we have 3 times O2, so that gives us 6 oxygens on the left, and we want 6 oxygens on the right. So now we're going to add in a 2. So if we put in a 3 there, it would be 3 times 3, which would be 9. So we now have our 6 there. So we have 6 oxygens on the left and a total of 6 oxygens on the right. So the oxygens look good. Now we need to balance these aluminums. So let's update the number of aluminums here. We have 2 times 2, so there are 4 aluminums. You're taking the coefficient and you're multiplying it by the subscript, so you get 4 here. And now we need to update the aluminums on the left. So we have 4 on the right, so we want to make 4 on the left. So do that final check yourself before you wreck yourself here, and you go through and you do, say, 4 Al on the left, and we have 2 times 2, so 4 on the right. Check. And we do 3 times 2, we have 6 oxygen on the left, and we do 2 times 3, we have 6 oxygen on the right. So that is fully balanced here. So why don't you guys go into your notes and finish the problems in aim number 1